Hello children, how are you all? Hope you all have completed the assignment and homework which I had given you in the previous classes. Okay, all right, very good. Okay, now we are going to see Unit 2. Okay, Unit 2 Optics. Okay, what is optics? Have you heard the name optics? It deals with light. Okay, it deals with light, glasses, like that. Okay, okay, let us see in detail. Now, what is light? Have you seen light? Yes, we are seeing light in every day of life. Okay, without light we cannot survive in this world, isn't it? Right. Okay, what is a light? It is a form of energy. It is a form of energy which travels in the form of waves. Okay, it travels in the form of waves. The path of the light is called ray of light. The path of the light is called ray of light, and group of these rays are called as beam of light. Group of these rays are called beam of light. Okay, any object which gives light, okay, any object which gives light is termed as source of light. For example, sun, okay, it gives light by itself. Okay, it gives light by itself. So some of the sources which emits their own light, so they are called luminous objects. They are called luminous object. All the stars, sun, okay, they are the examples for luminous objects. Okay, we all know that we are able to see objects with the help of our eyes, but we cannot see any object in the dark room. Can you explain why? If you need to see the objects, then you have to make the light, isn't it? So we can see the object only when the light is made to fall on the object, and the light reflected from the object, and it is viewed by our eyes. So you would have studied about reflection and refraction, okay, in your previous classes. In this chapter we will discuss it, about the scattering of light, images formed by convex and concave mirrors, lenses, human eyes, and optical instruments like telescopes and microscopes. Okay, so all these things we will study detailed in this chapter. Okay, okay, what is a light? It is a form of energy. Tell with me, it is a form of energy. How does it travels? It travels in the form of waves. It travels in the form of waves. Okay, what is the path of light called? It is called ray of light. It is called ray of light. If there are group of rays, then we will call it as beam of light. Then we will call it as beam of light. Okay, if an object gives out light, it is called source. It is called source. If the light is given by its own, if a object gives a light by its own, it is called luminous objects. It is called luminous objects. Okay, like stars, moon, sun, etc. Okay, have you understood, children? Right. Now let me tell the properties of light. Okay, properties of light. Okay, what are the properties of light? There are many properties. Okay, it can travel very fast, it is dual in nature, it travels in a straight line. Okay, it can vary in intensity, it interacts with the matter, it is comprised of many colors. Okay, light carries energy and information. Okay, these are the 7 properties of light, but there are most important properties. Okay, most important properties which is given in your book. Okay, you have to study it thoroughly. It is a important 5-mark question. Okay, light is a form of energy. It travels along a straight line. It travels along a straight line. Okay, it does not need any medium. Okay, it does not need any medium. Okay, air, water, glass, something does not need. Edume thevalla, in the medium thevalla. It can travel in a vacuum also. It can travel in a vacuum also. Okay, the speed of the light is c equal to 3 into 10 to the power 8 meters second to the power minus 1. That is the speed of the light. Okay, light is in the form of waves, so it is characterized by a wavelength. It is characterized by a wavelength and frequency. Okay, characterized by a wavelength and a frequency. Okay, then different colored light has different wavelength and different frequency. Okay, now among the visible light, okay, VIBGR, okay, the rainbow color VIBGR. So the violet light has a lowest wavelength and the red light, okay, the red light has a highest wavelength. So when the light is incident on an interface between the two media means, okay, air and a glass. Okay, see, there is a glass and in that glass it is filled with air. Okay, in the top or bottom, air is always, air particles are there. So when light is incident on the glass, now the light is incident on the glass media, what happens? It is reflected and partly reflected and partly refracted. Partly reflected and partly refracted. Okay, have you understood, children? These are the most important properties of light. Now, refraction of light. Okay, when a ray of light travels from one transparent medium into another, okay, obliquely, okay, obliquely, okay, the path of the light undergoes deviation. Path of the light undergoes deviation. This deviation of ray of light is called refraction. This deviation of ray of light is called the refraction. Okay, refraction takes place due to the difference in the velocity of light in the different media. Refraction takes place due to the difference in the velocity of light in different media. The velocity of light is more in a rarer medium and less in a denser medium. Refraction of light obeys two laws of refraction. First law of refraction, second law of refraction. Okay, during refraction, light bends on passing from air to glass and again on passing from the glass to air. Okay, see the picture. Incident ray, the reflected ray and refracted ray. Also emergent ray. This is known as refraction of light. When a ray of light travels from one transparent medium into another, okay, air and glass, okay, light is reflected and refracted. What are the laws of refraction? What are the laws of refraction? There are two laws. Okay, first law of refraction, second law of refraction. Okay, the first law is called Snell's law. Okay, no, the second law is called Snell's law. Okay, second law is called Snell's law. Sin I by sin r, sin I by sin r equal to mu2 by mu I, which is denoted here as n. Okay, the ratio of sine of the angle of a incidence and the sine of an angle of a refraction is equal to the ratio of refractive indices of the two media. This law is known as Snell's law. Okay, do you understand? Refractive index gives an idea of how fast or how slow the light travels in a medium. The ratio of speed of light in a vacuum to the speed of light in a medium is defined as a refractive index. Okay, that is mu. That is the refractive index. The speed of light in a medium is low if the refractive index of the medium is high. Okay. Now, when the light travels from a denser medium into a rarer medium, the refracted ray is bent away from the normal, drawn to the interface. When light travels from a rarer medium into a denser medium, the refracted ray is bent towards the normal, drawn to the interface. Have you understood, children? These are the second law of refraction. What is the first law? The incident ray, the refracted ray and the normal lie on the same plane. Okay, we may tell it as first law, second law. Okay, no problem. The incident ray, the refracted ray and the normal to the reflecting surfaces all lie on the same plane. Okay, first law, second law you have to study thoroughly. Okay. Now, dispersion. What is dispersion? Separation or splitting up of a composite light into its constituent colors is called dispersion. Separation or splitting up of composite light into its constituent colors is called dispersion. Okay? Medium that separates lights to its constituent colors is called dispersive medium. Medium that separates light to its constituent color is called dispersive medium. Sunlight is made up of various colors. Okay? It can be splitted to the same sequence of colors as that of rainbow when passed through the prism. Dispersion is found by Newton. Vacuum or air is not a dispersive medium. Okay? What is dispersion? Separation or splitting up of a composite light into its constituent colors is called dispersion. A medium that separates light to its constituent colors is called dispersive medium. Sunlight is made up of various colors. It can be splitted to the same sequence of colors as that of rainbow when passed through a prism. Dispersion is found by Newton. We know that sun is the fundamental and natural source of light. When we know that sun is the fundamental and natural source of light, if a source of light produces a light of a single color, it is known as monochromatic light. On the other hand, a composite source of light produces a white light which contains light of different colors. So, sunlight is a composite light which consists of light of various colors of various wavelength. So, another example for a composite source is a mercury vapor lamp. What do you observe when a white light is refracted through a glass prism? When a beam of white light or composite light is refracted through any transparent media such as glass or prism, it is split into a component of color. See the picture. There is a person having a glass in his hand. When a beam of white light is passed on it, what happens there? It is split into component colors. That is known as the dispersion of light. A band of colors is termed as spectrum. That spectrum contains violet, indigo, blue, green, yellow, orange and red. So, these colors are represented by VIBGYOR. Why do we get the spectrum when white light is refracted by transparent medium? This is because different colored lights are bent through different angles. Okay? See in the second picture, there are 7 angles. Okay? So, in 7 angles, each and every area we are getting different colors. So, this is because due to the different colored lights which are bent through different angles. So, that is the angle of refraction for different colors. Okay, different for different colors. So, angle of refraction is the smallest for red and highest for violet. So, from the Snell's law, we know that the angle of refraction is determined in terms of refractive index of the medium. Hence, the refractive index of the medium is different for different colored lights. This indicates that refractive index of a medium is dependent on the wavelength of the light. Okay? Do you understand, children? This is the dispersion. Now, scattering of light. What is scattering? When sunlight enters the Earth's atmosphere. See the picture. When sunlight enters the Earth's atmosphere. See second one, sunlight is entering the Earth's atmosphere. Okay. The atoms and molecules of different gases are present in the atmosphere, isn't it? Various atmospheric particles, okay? Atoms and molecules are present in the atmosphere. What happens? That refract the light in all the possible direction. This is called the scattering of light. Okay? Sunlight enters the Earth's molecules and it refracts the light. Now scattering happens, that is called scattering of light. In this phenomenon, the beam of light is redirected in all the direction when it interacts with the particle of medium. The interacting particle of medium is called scatterer. That is called scatterer. Okay? That is the scattering of light. Okay? Scattering of light is the deviation of light rays from its straight path. Okay? As light propagates through the atmosphere, travels in a straight path until it is obstructed by a dust or gas molecule. புரியுதா? சன்லைட் வந்து என்ன பண்ணுது? டைரக்டாக அந்த லைட் ரே வந்து எர்த்தோட பார்ட்டிக்கலில் படுது. அது ஸ்ட்ரெயிட்டாக தான் வந்துட்டு இருக்கு. ஓகேவா? ஸ்ட்ரெயிட்டாக வந்துட்டு இருக்கு. ஃபர்ஸ்ட் பிக்சரை பாருங்க, இன்சிடென்ட் லைட் ரேஸ் ஸ்ட்ரெயிட்டாக வருது, மாலிகுல்ஸில் பட்ட உடனே அது என்ன ஆகுது, டைரக்ட் ஆயிடுது. பாரு எத்தனை லைனாக ரீடைரக்ட் ஆகிருக்கு. ஸோ அப்படி செதறிடுது. தட் இஸ் த ஸ்கேட்டர்டு லைட், தட் இஸ் த ஸ்கேட்டரிங். ஓகே, ஹேவ் யூ அண்டர்ஸ்டுட் சில்ட்ரன்? Now, have you noticed the clouds? It appears in white color, isn't it? Why the clouds are in white color? Clouds are white because their water droplets or ice crystals are large, enough to scatter the light of a 7 wavelength. Okay, the component colors of the white light: red, orange, yellow, green, blue, indigo, violet, which combine to produce a white light. Have you understood? Clouds are white because their water droplets are large, enough to scatter the light of 7 wavelength. So white color is enabled to scatter 7 wavelength of colors. That is the VIBGYOR. So which combine to produce a white light. So the cloud droplets scatter all wavelength of visible light, creating the appearance of white clouds. Hence the clouds are in white color. It is able to scatter 7 wavelength called VIBGYOR. Okay, hence the clouds are in white color. Now, what are different types of scattering? Different types of scattering. When a beam of light interacts with the constituent particle of the medium, it undergoes many kinds of scattering. Based on initial and final energy of the light beam, scattering can be classified into elastic scattering and inelastic scattering. What is elastic scattering? Energy of the incident beam of light and scattering of a scattering beam of light are same. Energy of incident beam of light, scattering beam of light are same. That is known as elastic scattering. Next, what is inelastic scattering? Energy of incident beam of light and scattered beam of light are same. Okay, that is known as inelastic scattering. What is elastic scattering? If the energy of the incident beam of light and scattered beam of light are same, then it is called elastic. If the energy of the incident beam of light and scattered beam of light are not same, then it is called inelastic. Okay. Now the scattering are further classified into Rayleigh scattering, Mie scattering, Tindal scattering and Raman scattering. Rayleigh scattering, Mie scattering, Tindal scattering, Raman scattering. Okay. Now, what is Rayleigh scattering? Okay. The scattering of sunlight by the atoms or molecules of gases in the Earth's atmosphere is known as Rayleigh scattering. This is a normal scattering. Okay. It occurs immediately. It occurs often. Okay. When a beam of scattering of sunlight by the atoms and molecules of the gases in the Earth's atmosphere is known as Rayleigh scattering. Okay, it occurs as a result of radiation being scattered by a particle which is smaller than the wavelength of the incident light. Okay, it is very weak scattering and depends very strongly on the wavelength. Rayleigh scattering is a weak scattering, so it strongly depends upon the wavelength. Okay, scattering produced by small particles is isotropic, so that is equal in all direction. Scattering efficiency is inversely proportional to the fourth power of the wavelength of light. Wavelength of light is lambda. So scattering efficiency is k lambda, that is proportional, inversely proportional to lambda power square. Okay. What is Rayleigh scattering law? Rayleigh scattering law states that the amount of scattering light is inversely proportional to the fourth power of the wavelength. This is the main concept. Amount of scattering of light is inversely proportional to the fourth power of its wavelength. Okay. According to this law, the shorter wavelength colors are scattered much more than the longer wavelength colors. So when sunlight passes through the atmosphere, okay, the blue color that is having shorter wavelength, isn't it? Red is having more wavelength and violet, blue, that is having shorter wavelength. So when the sunlight passes through the atmosphere is passing through the atmosphere is full of which color? blue color. Okay, so it is having a shorter wavelength. Now what happens when sunlight passes through the atmosphere? The blue color is scattered. Blue color is scattered to a greater extent than the red color. Red color is having a longer wavelength. So this scattering causes the sky to appear in the blue color. Hence the sky is in blue color. So at sunrise and sunset, during sunrise and sunset, the light rays from the sun have to travel a large distance in the atmosphere than at noon. Hence most of the blue light are scattered away. Okay, during the sunrise and sunset, have you noticed the sky? Is it in blue color? No. Why? Because the light rays from the suns have to travel to a larger distance in the atmosphere. So most of the blue lights are scattered away because it is having a shorter wavelength. Hence only red lights get least scattered. So it reaches the sun. Have you understood? To reach the sun, the light rays are very distance away from the sun. So to reach the sun, it has to travel a longer distance. So the blue light cannot travel the sun easily because it having smaller wavelength. So to reach the sun, only red light is having the more power, more wavelength. So the blue colors are scattered away. Only red color and orange color. Okay, during sunset and sunrise, we are able to see that colors only. It is due to Rayleigh scattering. Therefore, the color of the sun is red at the sunrise and sunset. During the sunrise and sunset, the color of the sun is red. This is due to Rayleigh scattering. Have you understood, children? Now, what is Mie scattering? Okay, what is Mie scattering? Mie scattering takes place when the diameter of the scatterer is similar to or larger than the wavelength of the incident light. It is also an elastic scattering. It is also an elastic scattering. What is elastic scattering? The energy, incident energy beam of light and scattered beam of light are same. Okay, that is known as elastic scattering. Okay, have you understood? Mie scattering is caused by pollen, dust, smoke, water droplets and other particles in the lower portion of the atmosphere. Okay, the Mie scattering is responsible for the white appearance of the clouds. Okay, white appearance of the clouds is due to Mie scattering. When white light falls on the water drop, all the colors are equally scattered, which together form the white light. Okay, what is Mie scattering? Scattering by a isotropic homogeneous sphere. Okay, scattering by a isotropic homogeneous sphere. Okay, next, longer wavelength scattered more than the shorter wavelength. Longer wavelength scattered more than the shorter wavelength. Okay, have you understood? This is the Mie scattering. Next, Tindal scattering. Have you studied Tindal effect? That is known as Tindal scattering. Okay, when a beam of light is passed through a colloidal solution in chemistry, I think you may have studied. Okay, when a beam of light is passed through a colloidal solution, the colloid particles scatter the beam of light and the path of the light becomes visible in the solution. Isn't it? The path of the solution is, the path of the light is visible in the solution. That is known as Tindal effect. Tindal effect can be seen when the light enters a room through a small hole. Okay, see the second picture. Have you seen this? In a dark room, if you open a single window, what happens? Light enters a room through a small hole. That is due to the scattering of the light of dust and smoke particles. At that time, many dust and smoke particles we are able to see by our naked eyes. That is known as Tindal effect. Okay, physics is full of nature. Okay, in our surrounding, in each and every places we can see physics and effects and laws of physics everywhere. In your home, okay, in your room, in your schools, in each and every places there is a physics. Okay, Tindal effect can be seen in a dense forest due to the scattering of light by a water droplets in mist, fog, mist, like that. Okay, that is also due to Tindal effect. Okay, when a beam of sunlight enters into a dusty room through a window, then its path becomes visible to us. This is because of the tiny dust particles present in the air of the room. Okay, this is a Tindal effect. Okay, the scattering of light rays by the colloidal particles in a colloidal solution is also Tindal scattering or Tindal effect. Okay. Now, Raman scattering. Okay, Raman scattering. When a parallel beam of monochromatic light passes through a gas or a liquid or a solid, a part of light rays are scattered. Okay, a small portion of scattered radiation has frequencies different from the incident beam. That is an inelastic scattering. Okay, inelastic scattering. Okay, the scattered light contains some additional frequencies, some additional wavelength. Okay, other than of the incident frequency. Scattered light contains some additional frequency. This is known as Raman scattering. Raman scattering is defined as the interaction of light ray. Raman scattering is defined as the interaction of light ray with the particles of pure liquids. Okay, Raman scattering is defined as the interaction of light ray with the particles of pure liquids or transparent solids, okay, which leads to a change in wavelength or frequency. Raman scattering is defined as the interaction of light ray with particles of pure liquids or transparent solids, which leads to a change in the wavelength. Okay, the spectral lines having frequency equal to the incident ray frequency is called Rayleigh line, and the spectral lines which are having frequency other than the incident frequency are called Raman line. Okay, this is the Raman effect. Okay, now you only study the Raman scattering definition. That's enough for you. In higher classes you have to study in detail about it. Okay, these are the different types of scattering. Okay, elastic scattering and inelastic scattering. Okay, elastic scattering, the energy of the incident beam of light and the scattered beam of the light are both are same. It is called elastic scattering. What is inelastic? If the energy of the incident beam of light and scattered beam of light are not same, then it is called as inelastic scattering. Okay, this is the scattering of light and the types of scattering. Have you understood, children? Now, lenses. What is lens? Have you seen lenses? Yes, everyone has seen. Okay, lens is an optically transparent medium. Bounded by two spherical refracting surfaces. Okay, a lens is an optically transparent medium bounded by two spherical refracting surfaces or one plane and one spherical surface. Okay, it is classified into convex lens and concave lens. Okay, lenses are made of transparent materials like glass or plastic. Okay, lenses are made up of transparent materials like glasses or plastics. Okay, each of a lens, two faces is a part of a sphere and can be convex or concave. What is a convex? Convex means converging. Okay, concave means diverging. Okay, if a lens is thicker at the center than the edges, it is called convex. Have you seen the convex lens? See in the picture, if a lens is thicker at the center and the edges are thin, it is called convex. Okay, what is a concave? Lens is thinner at the center and the edges are thick, that is known as concave and diverging. Okay, parallel rays will be converged to meet at the focus in convex lens. Okay, since the rays going through it will be spread out in diverging lens. Okay, have you understood? Right. Now, types of lenses. Converging lens, diverging lens. In converging lens there are 4 types, diverging lens there are 4 types. Okay, plano-convex lens, plano-concave lens. Okay, there are various types. Okay, what is plano-convex lens? It is one of the faces of a biconvex lens. Okay, one of the faces of a biconvex lens. What is plano-concave lens? If one of the faces of a biconcave lens is plane, it is known as plano-concave lens. Okay, have you understood? These are the types of converging lenses: convex lens, biconvex lens, plano-convex lens, positive meniscus. What is divergence lenses? Concave lens, biconcave lens, plano-concave lens, negative meniscus. Okay, these are the different types of lenses. Have you understood, children? Right. Now it's time for your homework. Okay, are you ready for homework? Right. From in unit 2, page number 16 to 19. 16 to 19. Study well, read the topics carefully and answer 10 one words from the topic. Write the 10 questions and answer from the topics. Okay, and write what are the different types of scattering. Different types of scattering. Properties of light. Properties of light. Page number 16, there are 8 properties. Okay, study well and write it as an assignment. Okay, and write the different types of refraction. First law of refraction, second law of refraction. Study well and write each and every point in it. Okay, okay, okay. These are for your homework and assignment. Study well and complete it. Thank you, children.